In this class, we are going to discussing about the very simple topic. The topic is how to draw the shear force diagram, bending moment diagram with easy manner, right? With easy manner. That means by looking at the object, you can easily draw the shape of your curve. That means whether it is a positive, that means a straight line, or it is a parabolic curve. That too, it is a positive slope or negative slope, or positive parabolic curve or negative parabolic curve, whatever it is. By looking at the object, by looking at the loading condition, simply you can easily draw the diagram, right? You can easily draw the diagram. How are you supposed to draw the diagram means by looking at these things. Just simply gone through of all those things, you can easily understand. Right, first let us consider a beam. Irrespective of it is a simply supported beam, cantilever beam, or whatever it is, first simply you can observe, imagine that it is a beam, right? You are having number of, you are having different sections we are having here. The straight lines will indicate the number of sections, right? So the number of sections are indicating the loading conditions, right? In the second case, it is a shear force diagram, and third one is a bending moment diagram, right? Now in this case, I already told you that one point in your previous classes, whenever you are having a no loading condition or a constant loading condition, you will get a straight line. Simply you will get a straight line in your shear force diagram. Please observe that, right? In your previous classes, you please observe that whenever you are having a no loading condition or constant loading condition, in a shear force diagram, we are having a constant. That means in a straight line. Simple. That means here indicates it is a no loading condition or constant loading condition. So in a beam, we are having a constant load. Observe that it is a beam. It is a constant loading condition. Immediately in a shear force diagram, we are having only straight line. Remember this point, only straight line, you will get only just simply a straight line. Simply straight line whenever in a beam you are having a constant load. In a beam we are having a constant load or no loading condition, simply saying no loading condition or constant load. On the particular case, constant loading nothing but simply from point A to point B you are having same effect. Simple. That means we are having no loading condition, you are having a straight line in a shear force diagram. So automatically in a bending moment diagram you are having a slope. That means straight line in a positive slope. Positive slope you are having continuous increasing positive slope. Right. Whether it may be increasing or decreasing depending upon the type of loading condition. It doesn't matter. Only you will observe that you will get whether it is a straight line or whether it is a slope or whether it is a curve. That is the only matters. Right. So first point is clearly observe that whenever you are having a no loading condition, in a shear force diagram, bluntly you can draw a straight line, and in a bending moment diagram you are having a continuous increasing slope. That means you are having a slope. You are having a slope, right? Right. Next, you can also naming those equations are whenever you are having a constant loading condition or no loading condition. No loading condition in a shear force diagram n equal to 0, in a bending moment diagram n equal to 1. Simply naming of those values. You can easily remember. Right? Constant load means straight line means n equal to 0 and slope means n equal to 1. Similarly. Next case is you are having a bending moment. In a beam, either you are having a point load condition or you are having a UDL value or you are having a UL value. Only these three are the possible cases. So this is a point loading condition. Second loading condition is UDL value. UDL means you are having a constant load. That means from this point to this point you are having a constant load. I mean you are having it may be acting in downward direction, it may be acting in upward direction. Suppose in a UDL, if it is acting on the downward direction, right, I have told you that whenever you are having a constant load, whenever you are having a constant load, that means here you are having a constant load n equal to 0. Remember the term constant load. Constant load means n equal to 0. Whenever n equal to 0, automatically in a shear force diagram n equal to 1, in a bending moment diagram n equal to 2. N is the degree. N equal to 1 means straight line. N equal to 2 means parabolic. Simple. N equal to 1 means straight line. N equal to means 1 means slope and n equal to 2 means parabolic curve. Parabolic maybe it is increasing or decreasing or whatever it is depends upon the type of direction of force we are having, depending upon the positive value and negative value, right? But remember how do you get your values? That means the shape of value. It may be slope or a curve. That is the thing you have to be remember. So here it is a constant loading condition n equal to 0. Automatically your slope is decreasing. decreasing slope, and you are having parabolic curve n equal to 2. So this is the basic things in order to draw your shear force diagram, bending moment diagram. Only 3 parameters: no loading condition, constant loading condition. Then automatically you will get remaining parameters. Orders are varying. N equal to 0. Only you are having orders are n equal to 0, n equal to 1, and n equal to 2. Only these 3 are you are having. N equal to 0 means you are having no loading condition. N equal to 1 means constant. N equal to 1 means you are having a slope. N equal to 2 means you are having a parabolic. Simply remember. Next, automatically you can remember your values based on the standard curves, degrees and slope. Degree means either is n equal to 0, n equal to 1, or n equal to 2. Right? Right. So here it is as whenever you are having n equal to 0, n equal to 0 means no loading condition. N equal to 0 means no load or constant load. Remember, n equal to 0 means it is a constant load. So you will get straight line. You will get straight line. Remember, you get straight line. Next, second one, if n equal to 1 means I told you that you are having some loading condition. How will you get some loading condition? Means based on your area. N equal to 1 means. So whenever you are having a n equal to 1, so you are having a slope value is positive. Slope value is positive, which will increasing continuously. Positive slope. And similar case, when n equal to 1, slope is negative. Right, when your slope is negative, both cases are possible depending upon type of your loading condition. Remember the degree value, whether it is n equal to 0, n equal to 1, or n equal to 2. That is very, very important. Second case is your curve. That is in bending moment diagram you are having a curve. Whenever you are having a parabolic curve, the degree is n equal to 2. That means this shape is available whenever you are having a positive slope, that is decreasing. Positive slope, whenever you are having a positive slope, slope is positive and this value is decreasing. Second, this type of shape is available whenever you are having a slope is continuously increasing. And this type of curve is available whenever you are having a slope is negative but increasing. Negative value is increasing. And this value is slope is negative and the value is decreasing. Likewise, you are having these kind of shapes. Only if you remember this table thoroughly, you can easily draw any kind of shear force diagram and bending moment diagram. Easily without, forget your quantify value, because quantify values are calculations, right? But the shape is very, very, many of the students are get failure. How you get, whether it is a straight line, whether it is a parabolic curve or parabolic straight line curve, so all those things they get confused. So if you remember this chart thoroughly, you can easily get, or you can easily understand, you can easily draw the almost all the type of diagram, shear force diagram and bending moment diagram based on these degrees of terms. Only you are having degrees n equal to 0, n equal to 1, and n equal to 2. Only these 3 you have to remember, right? In the next class, based on these relations, how you supposed to draw your shear force diagram and bending moment diagram, you can easily understand. Thank you.